Okay, for this next part, there are a couple things I'd like you to really try to do on your own. You're going to need to probably hit the pause button. I mean, I will kind of maybe mention right now that some of these, an answer is already given within the slide. So kind of sorry about that. But I want you to think about these as much as possible and, do make good use of the pause button and so on. So what would z equals z equals -2, what would that look like? All the points x, y, z which satisfy the property that z is equal to -2. Okay, it happens to be a horizontal plane, horizontal from the standpoint of z being the vertical axis, if z is height. It's just that this plane, it would be parallel to the xy plane, but 2 units below. So then think about what z equals 2 is, what x equals -5 is, what x equals 5 is, y equals -4. Oh, and here's a fun one. Think about what x squared plus y squared equals 9 would look like. Now this is actually an infinite cylinder of radius 3. If you normally think about the xy plane, x squared plus y squared equals 9 is a circle of radius 3. But then if you think about this equation in the context of three-dimensional space, well, the z-coordinate isn't mentioned. So it doesn't matter what the z-coordinate is. Meaning you take that circle that sits in the xy plane of radius 3 and just raise it up and down, and everywhere you raise it up or down, all of those points you mark or you fill in, those are all part of this shape. It's basically many, many circles just stacked and sitting on top of each other or below each other. Then think about what x squared plus y squared equals 9 and z equals 1 also has to be satisfied might look like. So this is a horizontal circle of radius 3 that hovers 1 unit above the xy axis. Okay, what about the distance between 2 points in three-dimensional space? Well, I'd want to do some kind of drawings a lot just like in the previous part. And there will be several uses of right triangles going on, right? So again, these points A and B are related to P1 and P2 in that they share some of the coordinates. I would dare you to take a look at these things. Basically, you need to, I won't go through the details right now other than to say that the Pythagorean theorem is applied twice. The result of one Pythagorean theorem is used in the other, and ultimately the result is a distance formula that, if you don't want to go through the details, at least this doesn't look too surprising given the distance formula we saw in two-dimensional space, right? Root difference of x coordinates squared plus difference of y coordinates squared plus difference of z coordinates squared.